Okay, this is GeoTrig. We're going to do logarithms part 3 today. I ended the last video with this particular problem on the bottom of the page of log base 4 of 8 equals x. And I kind of stopped because I was like, you know what, that's a slightly different method, and I wanted you guys to get really used to that other method before we moved on to a little bit more complex version. So here it is. Now, as I have here, I found this and I liked it. So steps for solving exponential equations with the same base. So yes, these are not actually logs. Some of them are logs, like this one starts off as logs. And if you follow the rules from before, it says, hey, switch it out of logs. And so you end up doing that, and you get 4 to the x equals 8. And now it becomes an exponential equation, because remember, you can switch the different forms. And that's where the problem lies. 4 itself, 4 to the first power is 4. 4 squared is 16. That means that the value of x is actually between 1 and 4. Or 1 and 2, sorry. And that's not as easy. I'm not going to guess and check. I mean, I guess we could, but that could take us a very long time. We could make a lot of mistakes doing that, so it's not worth it. So I say we go through these steps. Okay, so number 1, you got to determine if the numbers can be written using the same base. If so, go to step 2. If not, stop and use steps for solving x with different bases. So we're going to get to solving exponential equations with different bases in the next video or two, actually in a couple of videos from now. We're going to do this now, where we're going to stick with this idea that the bases can be written to be the same. So if you look at 4 and you look at 8 and you kind of think back to yourself, 4, wait a minute, 4 is actually of a base 2. Isn't that just 2 squared? And if I took 4 out, would it be okay if I put in there 2 squared instead? And I hope the answer would be yes, because you can switch for equivalent parts. And then if you go over here to the 8, 8 can actually be 2 to the third power. So now what you have is 2 to the second power and 2 to the third power. The bases are the same. Now it says in step 2, it says, rewrite the problem using the same base, which we just did, and then it says use the properties of exponents to simplify it. Here we go. We got 2 squared to the x power. That means it's a power of a power, and a power of a power says that you should multiply. And so now what we have is that 2 to some power is equal to 2 to some power. And if you notice that the only way for these two things to be equal, with the bases to be the same, is if the exponents were the same. And that step number 4 says drop. If the bases are the same, you can drop them and just set their exponents equal to each other and then solve, divide by 2. So x is equal to 3 over 2 or 1.5. So that is how you're going to do this. Okay, so let's take a look at this one. This one is 25 to the x power equals 125. And so on the same lines, do you guys necessarily notice that 25 squared is going to be 625? That's too big. 25 to the first power is only 25. Okay, here we go. But you should notice that 25 and 125 can be of a power of 5. So 5 squared to the x is 5 to the third. Now I chose this one. It's going to look pretty similar to the last one. So it becomes 5 to the 2x equals 5 to the third, or 2x equals 3, or x equals 3 over 2 again. So yes, could you have the same answers a couple times? Sure can. That is not an issue. The next problem is, how about 4 to the negative x equals 32? So now we're going to bring in some negative exponents, and we're still going to have to get this idea of common bases. So the common base here is, I'm hoping you guys can see it, is 2. So 2 squared is to the negative x power is 2 to the fifth power. So it'd be 2 to the negative 2x equals 2 to the fifth. The bases are the same, so negative 2x equals 5. Divide by negative 2, and x is equal to 5 over negative 2. And so therefore we solve for x. So that's what we're going to be asked to do over and over and over again. Now I got one more problem to do with you. So let's try 4/9 to the x power equals 8 over 27. Now they're both fractions. That's okay. Just got to realize is that somehow, is there a power, some magical base that would give you a 4/9 when brought to a power, and brought to a different power, 8 over 27. So the way I like to do these is just look at the tops, 4 and 8. Wait a minute, 4 and 8, that'd have a 2 in it. Ooh, okay. And then 9 and 27, I think there's a difference or this common ratio, this common number of 3. So wait a minute, what if I said 2/3? And I square that 2/3. Wouldn't that get me 4/9? And all of that is obviously to the x power because I'm not touching that, I'm not moving that. And then that would equal again 2/3 to some power of, oh, looks like 3 to give me that 8/27. So that means that this is 2/3 to the 2x equals 2/3 to the third. Again, 2x equals 3, x equals 3 over 2. And that is how you're going to end up doing problems that have different bases, but yet they can be written with the same base. So your homework for this one is actually going to be a log joke, and I will post that hyperlinked into your homework. Have a great day.